This video contains information on how the users can access the current alerts from the different sources. This is the video tutorial for the visualization of alerts and warnings in the aqua3S platform that has been developed by the UNEXE and the CERTH. Specifically, the video contains information on how the user can access the current alerts from the different sources, and how he or she can adapt the thresholds of the devices. In general, the alert screen is data-driven and based on entities, defined on a pilot-by-pilot basis. This allows information for devices, satellites, social media, CCTV, and drone to be visualized on demand, which results in the top selections of the alerts screen changing on a pilot-by-pilot basis. Starting with the Device Current Reading tab, it presents the user with the characteristics of the devices for the pilot. The data is the same as used in the map view, but unlike the map view, the current settings view is presenting device data in a tabular text file format so that all sensors can be seen in one place and without using marker color coding to show device state. Moving on to the Device Alerts tab, it comprises of two components, Set Alerts and Current Alerts. The Set Alerts screen allows users to set the minimum and maximum values, with a minimum value being used for under-bottoming, which means that if a value is recorded below this value, an alert is triggered, and over-topping, which means that if a value is recorded above this value, an alert is also triggered. There is also an active tick box, which allows users to deactivate alert checking for given devices. The Current Alert screen displays a list of devices that are currently triggering alerts, and it is ordered by recency, which means that the most recent alerts are displayed first. Like the map view, the Current Alerts screen report devices that are offline as triggering alerts. Moving to the Device Anomalies tab, it comprises of four components: Anomaly Ranges, Current Anomalies, Historic Anomalies, and Anomaly Settings. Like the alerts, when new data is collected for a device, it is processed against the relevant anomaly setting data, and like the alerts, a table of current anomalies is maintained to better understand how the anomalies work. Let's have a look at the Anomalies Settings tab. Like the alerts, anomalies are raised when devices go outside of minimum or maximum values. Unlike the alerts, anomalies use a weekly set of minimum-maximum values, as the graph shows. This data is collected from historic device readings. Each device has a blue line for minimum values and a black line for maximum values. The red and purple lines show the corresponding alert, maximum and minimum values. The gap between the alert and anomaly ranges show how much more sensitive anomaly detection can be in comparison with alert detection. Often anomalies will indicate impending issues long before alert are raised. So let's move to the current normal is to see if we have any anomalies. Apparently, there are no anomalies in the system. Moving to of the Device Anomalies tab, it comprises of four components: Current Readings, Current Anomalies, Historic Anomalies, and Anomaly Settings. Like the alerts and anomalies, when new data is collected for a device, it is processed against the relevant anomaly setting data, and like the alerts, a table of current anomalies is maintained. Unlike the alerts and anomalies, anomalies are processed against devices that are part of the APANET model of the water distribution network. To better understand how the anomalies work, let's have a look at the Anomaly Settings tab. Each device that is part of the APANET model has a week-long set of simulation data, of flow or pressure data. When new data is received for an apanic device, the value is compared using an exponential moving weight average algorithm. Like the anomaly graphs, the apanomaly graph displays alert minimum and maximum values, showing that the apanomaly approach is far more sensitive to change, and like the anomaly approach, this allows issues to be raised long before they are detected as alerts. Going to the current anomalies, we can see the existing apanomalies. Finally, apart from devices, there are also tabs that record the alerts from the other sources as well, including the alerts from satellites, from social media, from drones, and from CCTV. In all cases, only the alerts that are currently active are shown. However, it should be noted that given the nature of data and how often they are retrieved, the time frame for which we consider an alert as active is different. Thus, for the satellite data, active alerts are considered the ones that have been triggered no later than 12 days ago for the flood detection and 5 days for Sentinel-2 from oil spill, algae bloom, and water bodies data. For social media data, active alerts are considered the ones that have been triggered no later than 4 days ago. Finally, for drone data, active alerts are considered the ones that have been triggered no later than 1 day ago. Thanks for watching.